Let's discuss common Python mistakes, from very simple to more complicated, why they occur, and how to avoid them. First, let's talk about the mistake of not understanding the correct scope while coding. Here is an example. We start for a value of money of 200 with an initial deposit of 100. Then we try to run the reset money function, which seems to initially work. But as you can see from the output, when we verify the value of money later on, it didn't change. What's more, the doubling function is completely broken and it crashed our code. This issue arises due to the usage of incorrect scope. We ended up with two different money objects, each inside its own scope, and we ended up with a third instance which tried to access a non existent object, which caused the entire function to fail. So, how do we solve this issue? We have two main solutions. The first, which I don't recommend, is using globals. By setting a variable as global in the function, we inform the system to use the variable from the global scope instead of creating a new one in the local scope. Here's how the code looks like with this change. As you can see, the code now works as intended. You might wonder why I don't recommend this approach as it seems to be working. The reason is, as projects grow, it becomes increasingly difficult to keep track of the scope and to make sure that you don't accidentally overlap variables, declare variables in a location that were previously declared. And using globals makes it very easy to accidentally miss these issues because many of those don't immediately crash your project. You can see this with the reset money function, as using that function did not crash the code, it just didn't work. Instead, the proper solution is to use both arguments and return values. Let's take a quick look at how this would work. By passing parameters to functions when needed and ensuring the values are returned, we achieve a more structured approach. This also makes it easier to modularize functions into different Python modules if needed. In any proper Python project, this is critical to do. Next, let's discuss what is referred to as mutable default arguments. We have a sample code where we have a list representing a deck of cards, and we created a function to draw a card. This function should create a new list if none is provided. Choose the random card from the deck and add it to the player's hand. Then finally, remove it from the deck. However, when running the code, we get an unexpected output. It seems both players seemingly share the same hand. Let's take a closer look at what is happening here. When we initialize a default value as a mutable variable, it is only initialized once. When the initial value is set, this becomes the default value for the empty variable. Now, two interesting things happen. First, player 1 hand refers to the value stored in the default hand parameter. Let's add a quick line to check the value. When player 2 draws without setting any initial values for the function, it uses the same hand object that player 1 initially used. Since we returned it and it is not a copy, now both player 1 and player 2 share the same reference to the same hand object in memory. Therefore, any changes to either hands reflect in both hands, even if we are no longer using a default parameter. To resolve this issue, the solution is very simple. Do not use any mutable variables as an argument. Instead, we can set it up with none as a parameter and then initialize it inside the function if it is not provided, like this. Now, the function works as expected. This concept is crucial because it will not directly crash your code if not done correctly, but more likely than not, you will be stuck troubleshooting an unexpected value later in your code without any clear indicator of the root cause, and it can sometimes cause you an issue several hundred lines later in your code. For the next mistake, let's explore how assigning and referencing values work, and the most common mistakes regarding misuse of copy or lack thereof. Many beginners in Python often confuse these concepts. The first segment with the equal sign mean that we are assigning a variable a value, but in reality it's not so simple. is often setting the reference and not only the value. If you are setting things such as strings or integers, then it is fine. But for any mutable value, such as a list, you're assigning the reference to the list and not the list itself. So if you change one of the two variables for the list, the other changes as well, since they are the same object. Does that sound familiar? Because this is the exact same issue that occurred in the cards example, with the default argument being set as a reference for multiple variables. Next, let's look at the double equality sign and the keyword is. Let's create two new variables, c and d. If you use double equals, it will return true for these values, since they share the same value. However, if we check what the keyword is, it will not return true, as they're pointing to two different objects, so they're not sharing the same object. Meanwhile, if we try the is keyword with a and b, you will see that it's true because they're indeed the same object. The solution to this issue for lists, if we don't have any nestings, is to use normal copies. A copy creates a new list which has the same members as values. So you can change each list separately without changing the other list. However, this still has a problem. If the internal member of the list is nested, meaning that it is, for example, a list itself, then this object is assigned to both lists, which again gives back the same problem of being the same object referenced in multiple times. The solution for that would be to use deep copies, which iterate over each item to create a completely independent copy. Let's see a few incorrect uses. If you use the wrong equals operator, you can have several results, some of which might cause direct errors, and sometimes might not cause an error, but sometimes do simply nothing at all. Next, if you do a shallow copy with a nested list, you can see that the inner items are shared between the objects as we discussed earlier, and both will change. Look at the correct usage now and compare the differences. By understanding these concepts and using the correct methods for copying, you can avoid unexpected behaviors and bugs in your code. Finally, let's look at mistakes regarding exceptions. One of the biggest mistakes that not only beginners but also many intermediate developers and even some experienced Python programmers make is accept blocks without specifying the exception details. This results in two significant issues. The first of which is silent failures and the inability to identify the cause of the issue. Even in segments where a failure is expected, having your code fail for reasons different than anticipated might mean unexpected values later on the line. When an error occurs due to these values, you have no way to recognize where it came from, as it failed silently. Let's look at some functions failing and check the errors we get. We don't really know what happened, and we end up with a lot of useless information. Did our division code fail due to dividing by zero, or was it due to an incorrect input, or was it something else entirely? We can't really know, and we don't really know how to handle this issue. Compare this to using the appropriate exceptions. By specifying the exception classes, such as zero division error, we can view expected exceptions and handle unexpected ones by seeing the exact error messages, or sometimes even not letting the application go on. Keep in mind that things like trying to exit the program with Ctrl-C is technically an exception. So if you catch all exceptions in a loop, for example, you might find that you cannot Ctrl-C to exit the program. As you can see from the output, all exceptions are handled correctly here with all details as needed. Those were some of the most common and hard to troubleshoot mistakes that can give you nightmares trying to figure them out. By understanding why they occur, you will save yourself countless sleepless nights of troubleshooting, and you will speed up your Python journey. Please comment on what other mistakes you found yourself making early on in your Python learning, what you want to see next, and if you found this useful, please like and subscribe, and have a wonderful day.